We've got the initialize section we talked about, setting their lifespan, lifespan variation, initial speed, speed variation, motion inheritance, and tracking motion inheritance. Tracking the motion inheritance, again, if our source particle is rotating and moving all around and we want those frags to continue to use that velocity information and rotation information to control the fragments, we can check that box. It's kind of a special situation. I'd recommend reading on the help file about that and taking a look at some samples. Okay, we took a look at fragment shape a little bit and how to set the fragment thickness. We can do something where we can, let's actually come back up. We're going to set the count down a little bit. You can see that dynamic face creation. Let's go ahead and hide this ground plane. It's not really helping us. And we can do something with down here under the fragment shape called thickness size dependence. And what this will do is it will take it'll look at each fragment particle and say, okay, really, how big are you? What's your size? And based on your size, we're going to affect your thickness. And so you can see right off the bat, it made quite a few of them much thinner. And so we might want to compensate for that further by increasing the actual thickness. This really becomes apparent when you get some very large particles mixed with very small particles. Let's set our count down somewhere in here. So you can see this guy here not as thick as this guy here. Okay, so let's increase this count a little bit more. And exclude closed frags. This is very useful if you have broken apart elements, single whole closed elements that you're breaking into fragments. This is what we're going to use when we look at the Pro Cutter example. I'll get into that in a little bit. We're going to disable that fragment threshold right now and just set this maybe about 3. What we want to do is take a look at the material handling. Because we're going to be using the source object, we used him, converted him into a particle, we're going to go ahead and, using his shape, so it's going to go ahead and use whatever materials apply to that source object, as well as his face IDs, which is very important. Let's go ahead and take a look. Let's disable TP and unhide all. Hide that guy and take a look at our cylinder 01. It's just a regular cylinder object. We're going to put an edit poly on him, select his faces, and we can see that he's using the kind of the default setup for cylinders, which has the end caps having an ID of 1 and the major radius portion having a ID of 3. We're going to go ahead and change that, and we're going to go ahead and set all of them to be 1. This is going to help us avoid some anomalies in our material handling. We're going to go ahead and set up a material. We've got one already created called Frag Tester. And Frag Tester's got a red material for slot 1, green material for slot 2, and blue material for slot 3. What we're going to do is we're going to take a look at these. First, of course, we need to apply this to our source object. Let's do that. So when we render him, of course, we just get this big red object. Right now it's all ID 1. What we want to take a look at is how do we control the actual fragments so that as and we'll turn him back on, hide our source, and let's take a look. As he fragments, you can see right now he's breaking into all these pieces, and we'll render this out. They're all red. It was all ID 1, and so all of these fragments right now are not being assigned any new materials yet, so they're just going to use the original source material. What we can do here under fragment shape and remaining shape is we have extra controls for changing the material IDs for the outside edges, which are kind of the normal outside facing ones, the edge material ID, which is the thickness edge that's created, or the backside, which is, of course, the inside portion of those frags. And so we can manually specify which ID we want to be applied to those. And we can go ahead and just set outside to 1 as well. So you can see these colors are being applied. Blue gets on the backside, green ID 2 on the edge, and of course ID 1 on the outside still remains red. Let's take a look. We want to actually look at the remaining mesh, which is up in here now. The remaining mesh is remember the source particle who's being eaten away and those fragments being born off of. We can do the same thing with him, set his outside to be 1, which is the same as it already is. We could set the edge to be 2, change that, and then these inside faces will turn blue once we set it to 3. And that's what we see there. This way we can keep kind of a consistent breaking apart look for the fragments in the source object. Okay, and there's this option all faces frag then die. This is useful if you're getting some refragmentation somehow. Definitely check the help file on how to use that one, as well as the alignment correction. If the particles are not being aligned properly when they're born, go ahead and check that. Okay, and kind of the last section here is the tessellate section. This is going to allow additional tessellation on the fragments and the source object. If we go ahead and turn this on, you can see now we get a whole bunch of much smaller, sharper faces. We get some tension controls where we can modify the tension value. You can see it really kind of whacks out some of this stuff, so you have to be careful when you use it. You've got methods for edge or face center. This will yield very different types of results. The face center I think is a little bit better, and got quite a bit of tension on that. The iterations are very useful. We'll go ahead and turn off the wireframe, but you can see that it's going to go ahead and progressively add more and more sharp small details into that fragmenting. So tessellation is very useful if you do end up needing to use it. Of course, also remember that you could turn on groups as objects and then access that fragment group as its own mesh and add some additional modifiers to it if you needed. That's certainly an option. And then of course we've got the update options, whether it updates always or only when rendering. And just be aware that all these extra faces and everything, if you end up caching your dynamic set, it's going to record that tessellation setting into that. And it's going to be a pretty large file. One other thing we wanted to mention on material IDs, if you cache the master dynamic or just this one dynamic set, it's going to record these material IDs into the faces that it creates. So keep that in mind. Okay, we'll turn off tessellate, and again, let's just take a look. We've kind of covered all the basics and simple things about setting up a simple fragment. Remember, threshold is one of your key things that has to be modified. Animate it from 1 to 0, 1 being no fragmentation, 0 being 100% fragmentation. Tell the fragments which group to be in, and tell them kind of how to create themselves, whether it's single faces, smooth and angle distance, or count. So. And of course you could also do things like on these born particles. You see Fragment's got a couple outputs here. It's got born particle. You could just apply a velocity to those born particles. And remember that this is, anytime you see a born particle output, anything you connect to that is only going to affect it at the time it's birth. It's just like using a particle age on born. Of course, you don't have to set that up. You could just connect it to the born particle, and when that particle becomes born, he's going to go ahead and get any operator connected here applied to him. Some good ones to use. If you want manual control over the velocity, you can do that, and that'll override the whatever's set in the fragment operator for speed. But watch out, then that'll negate any motion inheritance. We could also add, another good one to do is spin, just to get some of those particles spinning. And we want to set that spin time kind of low, probably in the 1 with some variation on it. You might even want some attack so that they don't start right away. The attack, remember, on spin is going to require kind of a fade-in time for the spin effect to take effect. But remember that spin's only being applied at birth, so it's really only a portion of this spin being applied, not the whole value. Okay, so that's pretty much a quick and simple view at Fragment. We're going to go ahead and do some more complex things where we look at a fragment using a fragment mask as well as lights in a couple other videos.